I'm Thisarani, and this is a video about a study done to determine the ideal projectile weight to counterweight ratio for a tabletop trebuchet. So trebuchets were ancient weapons used in ancient China, and they were introduced to Europe in the 13th century, where they were used to lay siege to castles. Later, trebuchets too were replaced by cannons and gunpowder, which were more effective, but earlier trebuchets were preferred over catapults due to their greater range and higher accuracy. There are two types of trebuchet. Traction trebuchets were invented earlier and used manpower to provide energy. Counterweight trebuchets were invented later and used a heavy counterweight to operate the lever. They were more effective than their earlier counterparts. In this study, a counterweight trebuchet was used. This is a line diagram of a counterweight trebuchet. As you can see, a trebuchet is essentially a first-order lever with the counterweight and the sling on either side of the fulcrum. The objective of this study was to find the ideal projectile weight to counterweight ratio for a tabletop trebuchet. The height of the counterweight when it was released was controlled. To control the mass of the projectile, the same projectile was used in each experiment. The projectile consisted of a ball carved from paraffin wax. The mass of the counterweight was increased by adding metal knots to a cloth pouch which was attached as the counterweight. The horizontal range of the projectile was measured using a tape measure. It was predicted that there would be a certain projectile weight to counterweight ratio where the projectile would have its maximum horizontal range. These materials were used to construct a tabletop trebuchet. The blocks of wood stated earlier were cut into the lengths shown in the diagram. This was the final working model of the trebuchet after it was constructed. This is a video demonstration of the operation of the trebuchet. The sling and the counterweight have been replaced to ensure the video's clarity. The following procedure was followed during the experiment. This was the primary data obtained after the experiment. After processing the data, the following values for the weight ratio, the average range, and the maximum range were obtained. The weight ratio was calculated by dividing the counterweight by the weight of the projectile. Two graphs were plotted using these data. The first graph was the graph of average range against weight ratio. As you can see, there is a peak between the ratios 64 and 68 in this graph. The second graph was the graph of maximum range against weight ratio. Again, there is a peak between 64 and 68. Therefore, we can conclude that the optimum ratio of projectile weight to counterweight for this trebuchet lies between 64 and 68. But the generalizability of these results is limited, as different trebuchets may have different ratios of lengths between the shorter arm and the longer arm of the throwing lever. The length of the sling and the friction between the moving parts of the trebuchet also differ between trebuchets. The following references were used in this study.